Ladies and gents, I hope that you completed the homework from yesterday, which represented the first 8 problems in the notes. But if you didn't, make sure, since I'm giving you extra time, that you get it done for tomorrow. Okay. Um, if you don't already have your notes out from yesterday, you can see them on the screen. Um, get them out so that we can finish examples 9 through 14. I'll give you a couple seconds here, but you can obviously also pause the video and get them out so you can copy them. I do expect you to all take notes on this and then get those completed. So, all right, so let's jump into it. Might as well have all kinds of fun because you guys know this is amazing stuff and you love it all. All right, first problem, example 9, is now going to talk about those other 2 rules that we didn't use yesterday. The fractions under the radical and no radicals in the denominator. So first question, example 9, the square root of 72 over 6. Okay, so notice, first thing, we have an issue, right? There is a fraction under the radical. We need to fix that. Now the easiest way, this one works out nicely, is just check, does that fraction, can we make it go away? Does 72 divided by 6 evenly? In this case, yes. 72 divided by 6 is 12. Oh, that's nice. Right, so now we've fixed that issue, but we're back to the first rule that says, can there be a perfect square radical inside of the radicand? No, there cannot be. Right, so we need to fix it. So I go, okay, what number on my list, the perfect square list that we wrote off to the left, goes into 12? Right, if you remember the half rule, take 12 divided by 2, you get 6. And just start from going less than 6. Well, that only leaves one answer. That's 4. So does 4 go into 12? Yes. So I can rewrite this. Square root of 4 times the square root of 3. What is the square root of 4? Well, the square root of 4 is 2. That is 2 times 3. The square root of 3. And since that would be it, I would reduce it and leave it just like that. All right, example 10. 9 over the square root of 3. Is that okay the way it is? No, right? Example, or the rule number 3 says no radicals in the denominator. I have the square root of 3 on the bottom. Okay. Now this is one that you're going to want to pay attention on, and luckily you have video format, so you can stop it and go back and listen to it again. When there's a radical in the bottom, that is an issue, and it's called rationalizing the denominator. And I'll even put that off to the side here. Rationalizing. Okay. To fix that, you're going to multiply the top and the bottom by whatever that denominator was in the bottom. So, because it was the square root of 3, I'm multiplying top and bottom by square root of 3. Okay? And here's why this works out so nicely. Okay? Let's do the top first, 9 times the square root of 3. Since this isn't a radical, I can't put these two together, so I just bring them over like this. On the bottom, though, now let's ask yourself, what's 3 times 3? You guys are all saying in your heads 9. Okay? What is the square root of 9? Well, that's 3. Run out of room here. Okay? Every time that you take a radical times itself, that with the radicands being the same, it's always going to work out to where the square root cancels out. Okay? That will work every time. That's why we do it that way. Okay? So just as every problem that you have where you have a radical in the denominator, multiply the top and the bottom by that radical, and that'll make so the bottom works out nicely. Now, this problem is not done though. 9 over 3 is a fraction that we can reduce. 9 divided by 3 is 3, and then the square root of 3 comes along for the ride. Okay, so there's that. Okay, then again, I can't do anything else with that square root of 3, so I'm going to leave it just like that. All right, so rationalizing the denominator. That's how I fix that square root on the bottom. Okay, example 11. 4 over the square root of 6. Okay, so this is the same issue as example 10. So hopefully you're telling yourself, hey, you got to rationalize this. So you're going to multiply the top and the bottom by the square root of 6. Okay, 4 times the square root of 6 is just 4 square root of 6. Square root of 6 times the square root of 6, that's the square root of 6 times 6 is 36. But that works out nicely because the square root of 36 is a nice number actually from our list, 36. So it's 4 square root 6 over 6. It should all be over 6. Actually, that's kind of ugly. Let's redo that. 4 square root 6 all over 6. There we go. And again, because this fraction is reducible, right, 4 on the outside, these two pieces right here, this piece and this piece, since those two are both outside of a radical, they can be reduced. 4 over 6 reduces to 2/3. And yes, you have to reduce. Okay? So take your time, rationalize. Again, rationalize by multiplying whatever the radical is on the bottom by top and bottom. Do your math correctly. Just take your time, multiply. Since they are the same, 6 and 6 is 36. Square root of 36 is 6. Okay, 4 over 6 reduces. Okay. Hopefully, again, you're writing all this down. If not, stop, go back, write it all down. All right, example 12, 8 over 12. And again, now we have an issue. We have a fraction inside of a radical. Example 9 was nice because it worked out to be a whole number when I did the division. Example 12, however, does not, but it can be simplified, so let's do that. 8 and 12 are both divisible by 4, so that reduces to 2 over 3. Okay. But that really didn't solve my issue. It made it a little bit linear of a problem, but it didn't solve my issue. Okay. So now what I'm going to do, a rule tells us in math that if I have radicals like that, I can split it and do the square root of 2 divided by the square root of 3. The square root of 2 on the top is not a problem. It's the square root of 3 on the bottom that's the issue. So again, same as example 10 and 11, I need to rationalize by multiplying the top and bottom by the square root of 3. So on the top, square root of 2 times the square root of 3 is the square root of 6. The bottom, the square root of 3 times the square root of 3 is the square root of 9. Square root of 6, there's nothing I can do to simplify that, so that's done. On the bottom, the square root of 9 is 3, so we're going to leave it like that. Okay, that would be a simplified form, following all of our rules, right? So under the radical is a 6, and there's no number on my list that goes into 6. There's no fraction underneath the radical, and there's no radical in the denominator. So I've made all 3 of my rules work. Okay, and the math gods are happy. All right, 2 more. All right, examples 13 and 14. 13, the square root of 3/10. Okay, this problem I can't fix it or I can't simplify it right now. 3 over 10 doesn't reduce. So I just have to do exactly what I did on example 12 by just splitting it into 2 little radical problems. So square root of 3 on top, square root of 10 on the bottom. Okay. Rationalize by multiplying top and bottom by radical 10. Square root of 3, square root of 10 is square root of 30. Square root of 10 times square root of 10 is the square root of 100. Because 10 times 10 is 100. The square root of 100 is 10, and then it's the square root of 30. Now I have to ask myself, okay, what's half of 30? 15. So the square roots are the perfect squares that are on my list that are less than 15 are 9 and 4. Does 9 go into 30? No. Does 4 go into 30? No. So this problem is completely simplified. You cannot, repeat, you cannot simplify a number that's in the radical and the number that's on the outside of the radical. That's why I can't reduce the 30 over 10. That's why this is my final answer. All right. Example 14, last one. 18 over 5. Okay. Same idea. Reduce if you can. So could I reduce 18 over 5? No, and it's nicer to leave it improper, so don't change anything about it. Leave it like it is. Then I get the square root of 18 over the square root of 5. Now the issue is the square root of 5 on the bottom, so I'm going to multiply top and bottom by the square root of 5. Square root of 18 times the square root of 5 is the square root of 90. On the bottom, square root of 5 times the square root of 5 is the square root of 25. Whoa. Okay. Next step, square root of 90 over the square root of 25 is 5. But now we need to check the top, right? Is there a number on my list that goes into 90 evenly? Well, Let's check. Let's start at what's half of 90? 45. So you're looking at your list off to the left now. So looking less than 45. So does 36 go into 90? No. 25? No. 16? No. 9? Yes. Okay. So I can rewrite this as the square root of 9 times the square root of 10 all over 5. Right? 9 and 10, because 9 times 10 is 90. One of my numbers has to be from my list. Okay. What is the square root of 9? 3. Square root of 10, and then all over 5. 3 over 5 can't reduce, so I'm done there. All right. So again, same. We actually used yesterday's rules in the what we did today. So we're just building on it. So now I want you to finish the second half of those notes, or of the worksheet. Now I know some of the problems are duplicates, so still try them though. Try them on your own before you look back on the notes and see if you can get them right. But then you at least have something that you can go back and check on. Okay, so I want you to finish this for today, and then the entire worksheet should be done for tomorrow when I get back, so that we can go over the entire thing and continue on into the next set of notes. All right, if you don't have anything, I don't have anything else, so you can ask questions amongst yourselves if you need to, but please make sure that you are working and complete the worksheet. Thanks.